Hello everyone, welcome back to TryHackMe Dojo, your practical learning hub for cybersecurity. If you are preparing for TryHackMe Security Level 1 certification, you are in the right place. In this series, we focus on real understanding, real lab, and real security thinking. In today's video, we are covering Windows fundamental theory, which is a core foundation for Sec 1. This is the knowledge you will rely on throughout your Windows labs and exams. So make sure you subscribe to TryHackMe Dojo, hit the bell icon, and let's begin with Sec 1 journey together. Before we dive in, let's look at what we'll cover in this session. First, we'll understand Windows file system, focusing on NTFS architecture and critical system folders. Then we'll move to users and permissions, covering groups, access control, and security boundaries. After that, we'll explore event viewer basics and how Windows logging helps in security analysis. We'll also discuss security artifacts, including the registry logs and forensic indicators. Finally, we'll talk about TryHackMe lab preparation, what to expect in Sec 1, and common pitfalls to avoid. Let's start with the basics. What is a file system? A file system controls how data is stored, organized, and retrieved on storage device. If it defines how files are named, how permissions are applied, and how metadata like timestamps is managed. In cybersecurity, understanding the file system is critical because many attacks, misconfiguration, and forensic investigation revolve around it. Windows uses NTFS, that is, New Technology File System, as its modern standard. NTFS is preferred over an older system like FAT32 because it provides enterprise-grade security, reliability, and performance. Unlike legacy systems, NTFS supports advanced permissions, encryption, journaling, and large file sizes, making it suitable for professional and corporate environments. For Sec 1, NTFS is one of the most important concepts you must understand. Access Control List. NTFS uses Access Control List or ACLs to, to provide granular file and folder permissions. This allows precise security control over who can access what. Journaling system. NTFS is a journaling file system, meaning it tracks changes to prevent data corruption and enable recovery after crashes. Encryption support EFS. NTFS supports EFS encrypting file system, which allows user to encrypt sensitive files at rest. File compression. It also supports native file compression, helping save disk space without third-party tools. Large file supports. NTFS can handle larger than 4 GB and volumes exceeding 2 terabytes, which is essential in modern systems. From a security perspective, NTFS is the backbone of Windows protection mechanism. Now let's look at some critical Windows folders that you will frequently encounter in labs. C/Windows. What does it contain? It contains a core operating system files, drivers, and system libraries. C/users. It's what it stores. It stores user profiles, documents, and application data. This is where attackers often look for sensitive files. C/program files used for 64-bit application installation. C/program files x86 used for 32-bit legacy application on 64-bit systems. C/Windows system32 contains critical system binaries and DLL required for Windows to function. C/Windows/temp stores temporary files which are often examined in security investigation because malware sometimes uses this directory. In Sec 1 labs, you will navigate these folders frequently. Let's talk about Windows users. First, we'll have local users. These are stored directly on the machine itself. Then we have a domain users, which are managed centrally via Active Directory in enterprise environment. Understanding this distinction is important because many attacks target domain environments. Now let's compare user privilege levels. Administrator. Administrator Users have full control over the systems, including security settings, software installation, and user management. Standard users have limited privileges, which helps protect system integrity and prevent accidental or malicious damage. In real world security, attackers often try to escalate from a standard users to administrator. Windows also include built-in accounts, built-in accounts, administrator, the default privileged account. Guest provides limited access for temporary users. System, the most powerful account in Windows used by operating system itself. In advanced attack, system level access is the ultimate goal. Windows groups and their purposes. Instead of assigning permission individually, Windows use groups. Groups make permission management easier and more scalable. Key groups include: first is administrator, full system control. Second is remote desktop users, allow allowed to connect remotely. Third is users, standard interactive access. Fourth is backup operators, allowed to backup and restore files. In security assessments, attackers often attempt to add themselves to powerful groups. Let's summarize the key security groups. First one is the administrator, can change security policies and system settings. Second is users, have standard access with limited modification rights. Third is remote desktop users, can log in remotely to the system. Fourth is backup operators, can backup and restore files, sometimes bypassing normal permission. Understanding these groups is critical in Sec1 labs. Now let's discuss the NTFS permissions. First is read, that is view file contents and properties. Second is write, create and modify files. Third is execute, run programs and scripts. Fourth is modify, read, write, execute and delete. Fifth is full control, all permissions including changing ownership. There is also an inheritance concept where child objects automatically inherit permission from parent folders unless blocked. Many privilege escalation vulnerabilities occurred due to in misconfigured permissions. NTFS permissions are applied directly to files and folders on the local system, whether accessed locally or remotely. Share permissions. Share permissions apply only when files are accessed over a network through a shared folder. Effective permission files. When both NTFS and share permissions apply, the most restrictive permission always wins. This is very important in security assessment. Now let's move on to Event Viewer, a crucial tool for security analysis. Windows logs to security, records authentication, events, privilege use, and policy changes. Windows logs to systems, record hardware, driver, and service related events. Windows logs application, records software related errors and warnings. Event Viewer is a central logging tool used for both troubleshooting and forensic investigation. In Sec1 lab, you will often analyze event IDs to detect suspicious activity. Thank you so much for watching. So that's wrap up for Windows fundamental theory for Sec1. In the next video, we'll move on to hands-on Windows lab where we'll actually apply everything we learned today. Also, I have attached a detailed notes for this topic in this description box below. So make sure you download them and revise along with this video. If you found this helpful, please like this video, share it with your friends preparing for Sec1 and subscribe to TryHackMe Dojo so you don't miss any part of this series. Until next time, stay curious, stay secure.